Integration by partial fraction and equating coefficient. Let's get started. So first of all, what is a rational function? A rational function is f of x equals to px divided by qx, which is the function has a fraction bar. We have one function divided by another function. The function in the numerator, I call that the dividend. The function in the denominator, I call that the divisor. So let's say I have f of x equals to x squared plus 2x minus 1 divided by 2x to the third plus 3x squared minus 2x. So first of all, I would like to factor the denominator. So from the third power to 3 distinct linear factors, x times 2x minus 1 times x plus 2. So the way you factor this is you factor 1x first, you factor 1x out, and then the third power becomes second power, the second power becomes the first power, and then you have a negative 2 at the end, and then you just factor that quadratic expression to 2x minus 1 times x plus 2. So from this to the a, b, and c, what did I do right here? So from these steps to the a, b, and c, I am trying to do partial fractions. So a partial fraction means I divide one big fraction into multiple smaller fractions. Again, partial fraction is I divide one big fraction into multiple small fractions. The a, b, and c, they are constant values. So if I ask you to just take a look at the a, b, and c, back to algebra, I ask you to add them, combine these three fractions into one fraction. What is the first thing that you are thinking of? The first thing that you are thinking of immediately is you are thinking about, what is that? You are thinking about common denominator, right? Because x, 2x minus 1 and x plus 2, they are three different denominators. You cannot just add the a, b, and c. No way, right? Again, the a, b, and c, they are just constant. So since you have different denominators, you cannot just perform the addition. You have to get a common denominator. The next question is related to common denominator. You have three fractions, x, 2x minus 1 and x plus 2. What is the common denominator? So the common denominator is simple. All you have to do is you just add them up, right? You just add them up. You just multiply them. X, 2x plus 1 and x plus 2. All right, just like this. Let's say 1/2 plus 1/3 plus 1 over 4. What is the common denominator? So the easiest way to do it, you just multiply them 2 times 3 times 4. Then you get a common denominator, right? And then this one, the common denominator is x times 2x minus 1 and then times x plus 2. So I have that right here. That is the common denominator. All right, so now let's break down the blue rational function into three smaller fractions. So starting from a right here, so we are looking at this line. So we have a over x. So that is what I have, a over x. How do you get the common denominator? Now follow me. Look at the denominator. I have x. I am missing 2x minus 1 and x plus 2. Compare the x to the common denominator. You are missing 2x minus 1 and x plus 2. That's why you have to multiply them on top and bottom. Can I just multiply the bottom? The answer is no. If you don't have the same thing on top, that means you are multiplying something other than 1. If you do so, you already changed the problem. So look at this. The common denominator, 2x minus 1 plus times x plus 2 divided by itself, that is just equal to 1. A over x times 1 equals to itself. I only changed the outlook of the fraction. I didn't change the problem. And then for b, you have 2x minus 1 in the denominator. So compare that to the common denominator. I know that I am missing x and the x plus 2. That's why you have to put that on top and bottom. And then the last fraction, c over x plus 2. Compare the denominator to the common denominator. I am missing x and 2x minus 1. So that's why I need x and 2x minus 1 on top and bottom. And then what is the next step? The next step is now the bottom, you have common denominator. So the top, you have to fully expand everything. So first thing first, you have to take a times 2x minus 1 and then x plus 2, and you have to open up the two products. So the 2x minus 1 times x plus 2, that is equal to 2x squared plus 4x minus x plus 2, right? So 2x times x is 2x squared, 2x times 2 is 4x, negative 1 times x is minus x, negative 1 times 2 is negative 2, and then the 4x minus x is 3x. And then for b, you have b, and then the b, you just bring the b down first, and then x times x is x squared, x times 2 is 2x, and then the c, x times 2x is 2x squared, x times minus 1 is minus x. So you have the letter A, B, and C in front of the expansion. So we are looking at line 1 right now. You have the A, B, and C in front of the expansion of the linear factors. All right, and then the next step is you have to distribute the A, B, and C. So A times 2x squared plus 3x minus 2. So you have A times that, A times 3x, A times negative 2, and then same thing for the B and the C. All right, so that is the end of line 1. You fully expand the numerators. Of course, you expand the linear factor first, and then you distribute the A, B, and C. So after the distribution is done, you have A times something, B times something, and C times something, right? That is line 2. So in line 2, what I want you to do is I want you to group the terms with the same power. So the square, how many squares do I have? 2x squared, bx squared, and 2x squared. 1 for A, 1 for B, 1 for C, right? So I underline them using a green line. So that means they are the second power. Where is the first power? A times 3x, and then B times 2x, C times x. They are the first power, so I use a yellow line to underline them. When you are doing this on paper, you can use a highlighter. And then the constant value, minus 2a, I use red line. So that is the end of line 2. And then in line 3, I am going to put all the second square, all the second powers together, and then all the first power together, and then all the constant value together. So the second power, I have that written in yellow. So A times 2x squared plus B times x squared times C times plus C times 2x squared. And then all the yellow, and then the red. And then what do you need to do next? Now, take a look at the green, the yellow, and the red. What is one thing true about the green? The green is there is an x squared. The yellow, there is x. The red, there is no x. Okay, so what you have to do next is we are trying to equate this to the given numerator. So do you still remember we have 2x squared plus x squared plus 2x minus 1 in the numerator? All right, numerator right here. We have that in the numerator. And then when you bring this down, what is the coefficient of x squared? The coefficient of x squared is 1. The coefficient of x is 2. The constant is negative 1. Or we can say the coefficient of the second power is 1. The coefficient of the first power is 2. The constant is negative 1. And then in line 4, I would like you to factor out the x squared, the x, and the constant. You don't need to factor anything out. So factor out the x squared and then factor out the x. Do we agree that now we have some constant value in front of the x squared, and we have some constant value in front of the x? And then we have a coefficient. Not coefficient. We have a constant. Now, look at the arrow. The arrow is the process of equating the coefficient. So x squared on the right hand side of the equal, what is the coefficient of x squared? X squared is right here. The coefficient is 2a plus b plus 2c. So you equate that to 1, because on the other side of x squared, we have 1. So 1 is equal to 2a plus b plus 2c. All right, so look at the system I wrote. 1 is equal to 2a plus b plus 2c. This is called equating the coefficient. And then what about the first power? The first power on the right hand side, we have 3a plus 2b minus 1. That is equal to the coefficient of the first power, which is 2. So in the second line of the system, we have 2 equals to 3a plus 2b minus 1. And then the last thing is you have to set the two constants equal. Negative 1 is equals to negative 2a. And then to complete the equating the coefficient, you have to solve for a, b, and c. Solving for a, b, and c, this system is not that hard, so you take care of the third line first. So -1 is equals to 2a, so a is equals to 1/2, right? And then you plug in a equals to 1/2 to the previous two lines. That will simplify the system a little bit, and then you either solve for a or you solve for b. So the technique is you have to solve one letter first. So after you got one letter down, the rest will be very easy. Okay, again, you have to take care of one letter first. After you got one number, the rest should be easy to knock down. Okay, so solving for a, b, and c, you have to solve the system of equation. So after you solve for a, b, and c, so a equals to 1/2, b equals to something, c equals to something, right? And then you put your a, b, and c back to this line, the very first line you wrote. So you put the a, b, and c back to the first line. So now the partial fraction is finished. So instead of taking the integral on the given rational function, which is hard, right? So if you take the integral of the given rational function, wow, that is hard. But if you take the integral of the three smaller fraction, that is easy. So that's why we have to learn partial fraction. Okay, and then the method I just introduced, the arrow, the orange arrow, the pink arrow, and the purple arrow, this process is called equating the coefficient. You look at the coefficient on the left side of the equal and the right side of the equal, and then you set them equal to build your system of linear equation. And then you solve the system, and then after that, you get the numerator of the three smaller fraction. The integration part should be very, very simple. Okay, so this is about integration by partial fraction, right? When you do integration by partial fraction, there are 4 cases. We rank them from the easiest to the hardest. So in case 1, the denominator is a product of distinct linear factor, which is the case I just showed you. And then in case 2, the denominator is a product of distinct linear factors, but some of which are repeated. So in number 2, which linear factor is repeated? The answer is the first one, x minus 1. X minus 1 is a linear function, right? So we call them a linear factor that is raised to the second power. So that is repeated. So in this case, we have another method to set up the partial fraction. And then in case 3, the denominator contains irreducible quadratic factors, none of which is repeated. As you can see, none of the factor is raised to some power, right? But the x squared minus 1 and the x squared plus 4, they cannot be factored. So we call them irreducible because the second power cannot be reduced. There is no way to factor these two quadratic factors. So this one requires you to set up a harder system. And then the last case is the hardest. The denominator contains repeated irreducible factors. And then this one we have irreducible, and then we have one irreducible and repeated 3 times because of the third power. So the x squared plus x plus 1 cannot be factored, and the x squared plus 1 cannot be factored, but this cannot be factored is raised to the third power. So the system in case 4 that is long and difficult to solve. When you take a test for integration by partial fraction, practice, and you should hope, pray that you don't get a case 3 or case 4 on the test. All right, but in the following video, I will give you example for each case. Case 3 and case 4, they are the hardest. Case 1 and case 2, they are not too hard, but they do take some time to do the equating coefficient and solve the linear system. All right, so that is the end of this video. If you think I gave you a good introduction, let me know in the comment below. Like the video, share the video for me. That really supports my channel. Subscribe to my channel. I will see you all in the following videos. Signing out for now.